this tutorial, we'll be talking about control flow in Swift. We will discuss the following topics: for-in loop, while loop, repeat while loop, if statement, switch statement, value binding, control transfer statements, labeling loops and conditional statements, and finally guard statement. Control flow is a programming means which allows the programmer to control how and when particular segments of a code are executed. There are a number of examples for control flow in Swift. For-in loop is one of them. We have seen for-in loop before. A for-in loop allows the repetition of a code segment for a particular range of values. While and repeat while loops also allow repetition of a code segment, but the repetition occurs while a condition, which is the while loop condition, is satisfied. If statement is something else that we have seen before. If statement is a type of conditional statements in Swift. With if statement, we can allow execution of a code segment if the if statement condition is true. Switch statements are somewhat similar to if statements. They are also conditional statements in Swift. They provide the possibility of the execution of certain code segment choices depending on the value of a particular parameter. We'll be going through these various control flow possibilities in the slides that I'll be using in today's tutorial. Let's start with the for-in loop. As I mentioned earlier, with for-in loop, the code which is confined within the body of the for-in loop is repeatedly executed, and the number of execution depends on the number of values which are provided by a loop parameter. The simplified syntax of a for-in loop is shown here, where we have the keywords for and in. In addition, we have a loop parameter, which is a group of known values. A loop parameter could be a value range, collection types including arrays, sets, and dictionaries, or string characters. In addition to the loop parameter, we have another parameter called temporary parameter here, which could be any temporary parameter by any name. The temporary parameter takes its value from the values provided by the loop parameter. For each value that the temporary parameter takes, the body of the loop is executed using that temporary parameter. In the next round of the loop execution, the temporary parameter will take the second value provided by the loop parameter, and using that value, the body of the loop is executed. This process continues until there is no more value left in the loop parameter. One thing to note is that this temporary parameter, as the name suggests, is a temporary value, and its scope is only within the body of the loop. Outside this loop, that temporary parameter is not recognized by Swift. Let's have a look at some examples of for in loop. Here is the simple case of using value ranges with the for in loop. What we have is a value range for our loop parameter ranging from 2 to 10. These values are given to our temporary loop parameter called x here, one by one. And for each value which is assigned to x, print x prints the value which is assigned. The process continues until the last element of the loop parameter is assigned to x. Here's a second example where we use dictionaries instead of value ranges. So for a variable x of type dictionary of int and double, the for in loop takes the values of the dictionary and assigns the key to the temporary parameter called key here, and the value of the dictionary entry to the temporary parameter called value here. The two temporary parameters, key and value, can then be used within the body of the loop for that particular entry of the dictionary, and then the next entry of the dictionary will be taken and the key and value elements of that entry are assigned to temporary parameters key and value, and the body of the loop is executed for those values. So this loop repetition continues until all the dictionary entries have been used up. If, when we are using a for in loop, all we are interested in is the number of elements within our loop parameter, and we don't actually need to use the actual values of these elements, what we can do is we can replace the temporary loop parameter by an underscore. That means we don't care about the actual value which are extracted from the loop parameter. We are only interested in the number of the values out of the loop parameter. So in such a case, for instance in this example, we will have values from 2 to 10. That means we are having 9 values, and this means that this loop is executed 9 times, and the body of the loop is run 9 times without actually using this particular values 2, 3, 4 up to 10 within the body of the loop. Similarly, when we're dealing with dictionaries, it is possible that we may not need one or both of key value pairs. So in such a case, we can replace the value that we do not need by an underscore. In this particular example, only the value out of each key value pair is used and is assigned to our temporary parameter value here. We don't worry about the key value. That's why we're using an underscore here. So the body of the loop is executed using only the value here, not the key value. With while loops, the body of the loop is repeatedly executed as long as the loop condition is true. The loop condition is checked at the start of each pass through the loop, and if the condition is true, the body of the loop is executed, otherwise the loop is exited. So the important thing is that with the while loop, the checking is done at the start of each pass through the loop. Here's the syntax of a while loop, where we have the keyword while followed by the loop condition. Then we have the opening curly bracket followed by the body of the while loop, and the loop is closed with a closing curly bracket. The condition of the while loop is a boolean, which is used to check whether the body of the loop is to be executed or not. Repeat while loops are similar to while loops with an important difference, and the difference is that the condition of the loop is checked at the end of each pass through the loop. So in the case of while loop, the condition was checked at the beginning of the pass, and here the condition is checked at the end. So the loop body is executed if the condition is true, otherwise it is exited, similar to the while loop, but because the checking is done at the end, the body of the loop is executed at least once. Here's the syntax, where we have the keyword repeat following by the opening curly bracket, body of the loop, closing curly bracket, the keyword while, and the loop condition, which is a boolean. Here are some examples of the while and repeat while loops. In the case of while loop, we have a variable x, which is of type integer and is initialized to be 0. So the while loop condition here is x less than or equal to 2. So as long as x is less than or equal to 2, this condition is true, otherwise it will be false. So for the first pass through the loop, this condition is true because x is equal to 0 and the body of the loop is executed. During that execution, x will be incremented to become equal to 1. So in the second pass through the loop, this condition is still true, and again the body is executed and x will become equal to 2. So when we go to attempt the third pass through the loop, the condition is still true, where as a result of the execution of the loop body, x will become equal to 3. But when we check whether we should enter the loop for the fourth time, we see the condition is no longer true and the loop is exited. So as a result of this operation in this example, the loop body is executed 3 times. Now let's have a look at a repeat while loop, where x again is a variable of type integer and is set equal to 0. With the repeat while loop, as there is no checking at the beginning of the loop body is executed once, at least once. During that run, x will become equal to 1, and then we check whether x is less than or equal to 2, which is the condition of the loop. And because that is true, we go through the loop one more time. X will be incremented to become equal to 2. We check, the condition is still true, so we go around the loop for the third time. We go through the loop and execute the body, and when we check the condition is no longer true, we jump out of the loop. So like in the previous case, the body of the loop is executed 3 times. So the outcome will be very similar. Now let's consider this example where x is initialized to 3 rather than 0. We check the loop condition. The loop condition is false and the body of the loop is not executed at all. It's not even entered. With the repeat while loop, on the other hand, where x is initialized to be 3, because there is no checking done at the beginning of the pass through the loop, the body of the loop is executed once. When x is incremented by 1, x will become equal to 4, and when the condition is checked, the condition is no longer true and we jump out of the loop. But here, because the condition was checked at the end of the pass rather than at the beginning, the loop body was executed once, even though the loop condition was false even at the beginning of the loop. So as a result, the loop body is executed at least once, and that is different to the case of the simple while loop where the checking was at the beginning of the pass and the body of the loop was never executed. Swift has 2 conditional statements. The first one is if, and the second is switch. Here we talk first about if statements. In the case of if statement, a segment of a code, in other words, the body of if statement, is executed if a certain condition, which is the if statement condition, is true. Otherwise, that segment of the code is not executed. Here's the syntax where we have the keyword if followed by the if condition, opening curly bracket, the body of the if statement, and the closing curly bracket. The condition is a boolean. We could also have if-else statements. With if-else statement, a segment of the code is executed if the if condition is true, but if it is not true, a different segment of the code, which falls within a clause called else clause, is executed. The syntax is shown here. We have the keyword if by the if condition, the opening curly bracket, the body of the if statement, I'm calling it body 1, closing curly brackets. So the open and closing curly brackets here are associated with body 1. They just indicate the limits within which body 1 falls. Following the closing curly bracket, we have the keyword else. Then we have the opening and closing brackets of the else clause. So else clause is what appears here. So the body of the else clause here, I'm calling it body 2, and this is what would be executed if the condition here is not true. If the condition is true, body 1 is executed, otherwise body 2 is executed. We could also have multiple if statements as opposed to a single if statement. In such a case, a segment of a code is executed if the first condition is true If the first condition is not true, but a second condition is true, the body of the second if statement is executed. If neither the first or second if conditions are true, a third condition is examined, and if that is true, the body associated with that if statement is executed, and so on. If none of the if statements conditions are satisfied, then we could have an else clause at the end, which provides a default code segment to be executed. Here's the syntax, where we have the first if statement followed by the first condition, and then the body associated with that first statement. Then we follow the curly bracket of the first condition by the keyword else if, and condition 2, which is the condition of the second if statement. Then we again have the curly brackets associated with the second if statement and the body which falls within those brackets. This continues for as many if statements that we need, and finally we will have an X clause with its own curly brackets and default body. Here are some examples of if statements. The first one shows the very simple case of a single if statement where we have a variable called x of type integer and set equal to 0. And the condition of the if statements is if x is less than or equal to 2. And if that is true, the body of the if statement, which in this case is a single print function, is executed, and the value of x in this case is printed. A simple if-else statement is shown here. So instead of just having an if statement, we also have an else clause. So if the condition of the if statement is true, this body is executed. Otherwise, this body is executed. In this case, because the condition is true, the body of the if statement is executed, not the default else clause. This example shows the case of multiple if statements with an else clause. So we have two variables, x and y, both are set to be equal to 0. The first if statement has this condition, which says x is less than or equal to 2, which in this case it is true. So as a result, y is incremented by 1. And the second if statement has a different condition, which is different to this one, which says x is greater than 2 and less than or equal to 3. If neither this condition nor that condition is true, the default case is executed, which corresponds to our else clause. It is possible that we do not have an else clause in a multiple if statement setup. That is shown here in this example, where we see we only have the two if statements, without the else clause. That means if these two conditions are not satisfied, the if statements have no effect on the performance of the code. This concludes the first part of our tutorial on Swift control flow. In the second part, I will be looking at other tools available with Swift's control flow, starting with the second conditional statement, switch.